All right. Hi, everyone, and welcome to today's session on controlling cloud costs. We certainly know there are a lot of options for webinar these days. I'm sure your inboxes are full of them. I know mine are. There's some great ones out there, but we want to thank you for taking time out of your day today to join us on this particular webinar. I'm Kelly Coleffel. I'm VP of Sales, Marketing, and Alliances with Hashmap, and I'll be moderating the webinar today. We're going to hear from Randy, get him introduced in just a moment. Also, a couple of notes. We are streaming this webinar live on our YouTube channel, so you can check it out there. I saw George and a few other people out there. The link is there for chat on YouTube as well, so definitely hit us up with some questions on that particular channel. Also, feel free to forward to anybody. If you're on Zoom right now and you want to forward that YouTube live link, feel free to do that. Questions, we will take them throughout in either the Zoom chat window or via YouTube, but we'll probably hold until the end unless there's something urgent. Randy's got a lot of information to go through, so pop your questions into either one of those chat windows. We'll be checking them out during the broadcast and make sure we get as many of those addressed as possible. If you do miss something, you miss a concept or something that's said, we're going to do a recording for today's webinar. It will be available on demand from the events page on hashmapinc.com, so you can catch it there. I think Randy will make the slides available as well that he's presenting. So again, everyone on all the channels, thank you for joining us and welcome to the Controlling Cloud Costs webinar with Hashmap. I'd say that in the last 3 years, we've worked across, 20, 25 industries on 200 plus data and cloud consulting services projects. It's been a lot. It doesn't really matter the size of the industry or really the size of the company, small, medium, large. One of the common themes that it seems like we hear repeated over and over again by almost everyone, whether they're in the cloud today or they're getting ready to move to the cloud, is how can I ensure that I don't get a surprise bill from one of my cloud providers that I wasn't expecting? I don't want that. Don't want to have to go back to my boss with that type of thing. Or how do I know I'm not just burning cash in my cloud accounts without getting the value that I'm expecting? And I mean, if we're all working from home today, and probably all of us have gotten a surprise bill. You get a water bill from a leak you didn't know about. You get an extra high utility bill during the summer or winter. Maybe you get a mobile or streaming service bill that wasn't what you thought it was going to be. And I think today's reality with COVID-19 and what everyone is going through globally is that every single company, regardless of size, industry, or geolocation, has to preserve cash and stretch OpEx as far as it will go. And there's tremendous value, no doubt, being generated across clouds and cloud services, but wasting money in the cloud is just not acceptable. It's not acceptable anytime, certainly not right now. So today we want to show you an approach to avoid burning cloud cash and getting surprise bills, and hopefully find a way to provide some much needed visibility to your organization and ensure that your cloud dollars are contributing as much as possible towards high value outcomes. So with that, I want to introduce today's speaker and presenter, Randy Pitcher with Hashmap. He is a data and cloud engineer, and he really works with the majority of our clients on some of the toughest data challenges. He, importantly, I feel like, is also a practitioner of saving cloud costs for us, for Hashmap. And he's going to share some great insights with you today that you can hopefully put into action right away to save money. So Randy, take it away.
Thanks, Kelly. Great intro. Can you hear me okay?
All good, yeah.
Oh, good, cool. Welcome everyone to our second virtual meetup. I'm really excited about this one. So let's dive in. First, we're going to talk a little bit about Hashmap. I know Kelly gave an overview, but I'll touch it from maybe a different perspective. Then we'll talk about cloud cost control as a concept and why it's so hard. What are the challenges that we see and what are the things we'd like to do? Then we'll cover the best section of the whole thing, which is the data stack. That'll be kind of a fun dive into how we got this data, how we process it and make it available for our BI tool. Then we will do a technical kind of sub deep dive into Snowflake streams and tasks. This is something that I think people ask for from the last meetup that we get a little more hands-on. So this is definitely going to be a technical session, and you can come back to this later and run the code yourself if you're interested. And then we're going to dive into reporting and monitoring, which is really more the executive decision-making section and how we actually action on the insights we generate with our data stack. And then we'll open it up to questions. So Hashmap, it's the place I work. We are a consulting company, and we work with data, all kinds of applications. We really help. I think of it as doing the plumbing that a lot of people don't find interesting, but I think is actually really interesting, so that you can focus on the dashboarding that you want to do, on the data science you want to do. A lot of people aren't hoping to do data engineering when they get started on an analytics project. So that's where we fill in the gap. When I think about Hashmap, I think of us in three major areas. We have data engineering experience and data engineers ready to jump on a project across all three clouds, in Snowflake, in any of your vendor neutral environments. We do on-prem, we do Hortonworks, Clouderas type stuff. We really do it all. It's about data for us. We also have cloud architects. This is a focus for us as we've seen more and more interest in migration to the cloud, is helping our clients in usually what is their first foray into the cloud environment. How do you successfully do your first cloud project? That's really where our cloud architecture comes in. And then lastly, and this is what I think really distinguishes us, we're trusted advisors. We're not in it for a one-off, quick hit, kind of one and done relationship. We want to succeed and have a long-term, value-driven relationship for the long term. And I think that separates us from some of the other body shops. So if you just need a coder to come in and do what you say for 2 weeks and then leave you alone forever, that's really not us. We're interested in bringing more context. But these three things don't really capture something that I think is important about Hashmap, and that's that we're a lot of fun. So the key thing that I want to drive today about Hashmap is that we make data engineering interesting. And I mentioned that before about the plumbing. A lot of people have this misconception that plumbing, which they know is a big portion of the actual work for analytics, that it's just boring kind of movement work. And really, it's not. There's a lot of approachability that can be had in this space if you explain things simply, if you insist on a simple, sustainable approach to data engineering. And I found that by leading with value first, by getting that first dashboard up as soon as possible, not in 3 months, we can get that spark of insight, that curiosity, you get buy-in from everyone. So those are the kind of projects that I really like to work on. It's what Hashmap focuses on. So let's dive in a little bit more onto cloud cost control and why maybe it's so hard. So cloud cost control, especially around multiple clouds, is tricky because you have multiple panes of glass. You have multiple places to digest your current cloud spend and to understand with different controls or different load times what you're doing. So in this environment, we're talking about AWS, GCP, Azure, Snowflake, all these services, they have their own cost environments. And if you have multiple AWS accounts, you may have multiple cost dashboards that you need to view to see everything in one spot. And it doesn't always give you the level of detail that you need. The visualization is also kind of slow and buggy and incomplete, depending on the service that you're using. And just overall, it's kind of painful. And this is independent of whether you start to blend the data. Just in an individual cloud, it can be tricky to get to the insight you really want. And then if you're not putting your cloud data in a single repository, a single warehouse for compute, you're not able to enrich it with additional context. I'm not able to add some of my HR data or add in some information about increased load on my application servers that might justify why I'm spending more in the cloud. So without that context, then we're really just searching for needles in a haystack. And really what we want to spend our time doing is analyzing the actual results and taking action. And speaking of taking action, let's talk about the core questions that we're trying to answer when we talk about cloud cost control, the business questions that are involved. First, which cloud environments are driving my monthly spend? This is a common question. I get a budget in a certain organization, and I can spend it across the different clouds that I use. How do I know where I should emphasize my cutback efforts? If I spend all my time trying to optimize my lowest cost spend, I'm only going to have so much benefit to gain. And then a common question in the cloud, should I pay up front to get better pricing? If your usage is very low and you don't know how much you will use, maybe it doesn't make sense to pay up front. But if you do have regular, consistent usage in a cloud, it's often better to pay up front and get a better rate. So you can drop your budgets, you can drop your spend by getting the same amount. And that's only really possible if you're able to answer the question of how much do I need? That's where analytics can come in really powerfully here. Is there something happening that needs my attention right now? Some proactive stuff that doesn't require me stumbling across a spike and asking the question and digging in. It doesn't require me to be a cloud expert. That's something that these analytics can help with. Why are my costs rising? And I think when we talk about cloud usage, a lot of people pay attention to the spike in usage for a specific day and you go fix that. But the kind of insidious, sneaking actual enemy here is slow rising cost. And you're not really sure why it's increasing. And that can be for a number of reasons. We want to get at the death by 1,000 cuts of small services that should be turned off. They're not used anymore. The person who created them left the company, that kind of stuff, and start saving money. And that's what it's all about, really. How can I save money? That's really what we want to do here. And when we think about this problem, I don't think these questions are revolutionary. Anyone would ask these questions if you had the data in front of you. And for those reasons, I believe that cloud cost control is a data engineering problem. It is not a problem of having the right cloud expertise or having the right finance background or the right business mind. We just don't have the data in the right spot. And if we did, which is a data engineering problem, then anyone can fix your cloud cost control issues. So let's talk about that. Let's talk about the data engineering side of the house and our data stack. So I'm going to show a slide here that is going to maybe be a lot all at once, but we will break it down into pieces. So this is our data stack today. The red lines are connecting data sources and ingesting them into my Snowflake environment. The yellow lines are my transformations that are orchestrated and continuously deployed. And the green line is my BI for developing dashboards and actually getting to the insights. And without that green line, all of this before is kind of fun and interesting, but it's not actually useful. So let's dive into each one of these pieces. First, let's talk about this Snowflake data source. And we're going to come back to all of this. So if this is too much at once, that's okay. We're going to come back to this. Let's simplify a little bit. Snowflake as a data warehouse exposes usage data as another database inside your environment. And I use Fivetran to grab that data and persist it in a Fivetran database. The reason is, if you just query this data in the Snowflake shared environment, it's going to be very slow. It has to do with the technical nature of how they share your live usage data back to you. But the short version is, if you query that with your BI tool, every query is going to take a long time. You're going to spend a lot of money. So instead, I batch every couple hours with Fivetran using a scheduled task that will grab this information and historize it in a source table in my Fivetran database. From there, I pick up the data with dbt on a schedule again, transform it in a way that makes it easy to consume for my BI tool, and save that into analytics. And then I power my reports. So it really is as simple as this, and all of this is modular. So if you aren't using Snowflake, you can use another data warehouse. They probably don't have this clean usage database for you, so this is a little trickier. But your extraction piece, it can be Fivetran, it can be Stitch, it can be Matillion, it can be custom build your own. I would say for me, Fivetran has helped me save so much time that it's been worth using a more premium tool, but there's no reason you can't use those other tools or build it yourself. And same with dbt. dbt is a powerful transformation tool, but if you are stored procedures on a schedule kind of shop, you can still take advantage of this. And then Looker, while it, I think, is uniquely positioned to do this specific kind of work very well, there are other alternatives you can use. If you're a Microsoft only place, you're forced to use Power BI, you can leverage that as well. So I won't drive this in on every one of them, but you don't have to use these exact tools to get the same benefit. The pattern is what's really useful. So let's talk a bit about the data frequency. So this is a data quality metric that I have here. This is actually in Tableau because it was kind of last second and I didn't have time to write LookML, but the real useful stuff is in Looker. And I'm showing how many records per day I have ingested over time. So I see down here, I have just a couple empty spots, and those are days I know don't have any compute usage. And for the most part, this usage looks right to me. So this is a great way to initially see, does my raw data have any obvious problems? From here, I have dbt transformations, and this is a lineage graph that dbt generates for me for my Snowflake usage computation. I have a number of source tables that I persist, but I don't do analytics on top of all of them. Some of them are just for log information, like query history. I don't aggregate. I don't have any dashboard for this. This is simply for me to query for investigation purposes. But my task usage history and my warehouse metering history, these are important pieces of information to understand my Snowflake spend. For anyone who uses Snowflake, I would say this is like a really broad statement that I think is mostly true. Your costs are driven by compute. They are not driven by storage. And that's so true for me that it would cost me more to run ingestion jobs in a single day to monitor my storage than it costs me for a month of actually storing that data. That's how big the difference is. So I am only focusing for Snowflake on the spending through warehouse credits. And I have some task usage history that helps me understand where that's being driven from. And the benefit of this data source is that it's minimal for transformations. I'm really just trying to capture it on a regular schedule so that the queries are fast. I do some manipulation of timestamps to timestamp no time zone, and I shift it to my current time zone in American Chicago CST time. And the reason to do this NTZ transformation is because the BI tools I found, specifically Tableau is one I know that has this bug. If you query it with a specific dedicated time zone, it will not query back to the database in the same time zone. So I found the best way to get the predictable response that you want and to have the correct data come back is to use a no time zone data type. And this solves all the problems for me. And then I just prune the columns that I'm going to use for Looker. I find that LookML is a lot easier to maintain if I only put the columns that I intend to use in that final table. And then I can manipulate the kind of data context at the Looker side. So that's all I'm doing for this. And I'm ready to go. Next is S3 Amazon data. So Amazon has cost and usage reports that you can configure in your accounting section. They will deliver your detailed usage to an S3 bucket that you configure. And once it's in an S3 bucket, we all know it's really easy to ingest that into Snowflake. I could have used a Snowpipe to do this information loading, but again, I use Fivetran. The big reason is that if this data ever changes shape in S3, that would break my CSV import. But with Fivetran, it adapts automatically to changing data. And I actually had a data change here that Fivetran caught, and it saved me hours of work. So from there, it's all really similar. I use my dbt scheduled transformations to go to analytics, and then I can process and view that data in Looker. Now, this is the similar chart that shows me the number of records per day that I am ingesting. And going back to October of last year, this is when I started recording our usage, but we have a big spike around November, maybe a month into doing this, in the number of records I ingested. And the reason is when I first set this up, I used a cheaper version of the export that reduced the amount of data by not telling me the individual IDs of the resources that I'm using. It would just report based on the region and the service family that the cost was in. But that doesn't really help me to tell me what to turn off. Because if it just tells me EC2 is high, how do I know where I should go and turn something off and focus my efforts? So just a simple UI fix, I added resource IDs. It warned me it would be more data, and it looks like it doubled the number of records that I add. But seamlessly, Fivetran picked up this change where now resource ID was being added, and it modified my table, and none of my pipelines broke. And it was just automatically able to pick this up. I modified my SQL to include the resource ID, and that was that. And this is the only two things I've ever had to do to set this up. And it's been not quite a year. In a couple months will be a year since we've been doing this seamlessly. And another thing to notice, I see no missing days here. So that doesn't mean the data is perfect. I actually know that the way that AWS writes this data, it sends a lot of duplicates because there's a lot of updates that happen after the fact, after you used it. So from a glance, this data looks like it could be correct. And I always like to do this as a kind of a gut check. The transformations on the AWS data, they're more complex, but there's only one data source. So in dbt, I have my source, which is just my raw data coming in from Fivetran. I stage it, and for me, staging is just time series manipulations. Then I get just the current data. I'm removing duplicates. And then I grab just the columns I need because there's like over 100 columns in this report, and a lot of them aren't really useful for my purposes. I take the columns I need and I put those in an AWS cost top table. and then I blend my costs into a Hashmap cloud costs. This is for investigating AWS, and then the broader Hashmap cloud cost table is used to power executive summary dashboards for folks that aren't going to dive into the details. They just want to know a top level number. How much am I spending across all clouds? The cleaning for the AWS data is a little more in depth, though the documentation is very good. The different columns and what they mean and how they got there is well documented in the AWS documentation. I do, again, that timestamp, no time zone transformation. That's important to do for your BI. Not all tools have this problem, but I know that Tableau still has the problem, and I've seen it happen in Spotfire in the past. I assume they use a similar mechanism. Then I remove line item duplicates from after the fact billing updates. So this data comes in pretty regularly, multiple times a day. And if after a certain run has been done, billing gets updated for the really kind of complex ways they calculate cost, I have a challenge because there is no line item ID that is unique across all the reports. So I have to find a way to filter through and know, is this a new record or is this an update to a previous record? That's the main challenge with this manipulation. And I'll explain how I did that a little later. I found a really great way to do it. Next, I convert account IDs to account names for Looker because the account ID doesn't mean anything to me. We have 3 different accounts. That's a really easy map to do. Then I prune columns just like I did before to grab just the columns that I need because, again, there's over 100 in this report, and that's just too much for someone to look at in Looker. And then something that's really interesting in Looker, and I didn't realize was a problem until after I built my dashboards, was that some of our resources in AWS, they have sensitive names, maybe the name of a client. And I can't publish that kind of stuff to people. So I hash them. I run a simple hash function. It was 4 lines or 4 characters to add to my lookml. And instantly, with the dashboards I already created, no additional work, it masked that data. So that was really powerful in Looker. These are the transformations I do. And this is what it looks like in dbt. This is the main kind of heart of the transformations. Up top, I do my timestamp transformations. Pretty simple stuff. This is the important part. You don't have to convert it to a time zone if you don't want to, but this I think most people should do. And then I hash. I found 4 columns that uniquely identify a specific item. The first is the resource ID, which is just the individual resource in AWS that this is referring to. The time interval that this responds to, this is the kind of billing interval that you would be working in. The specific usage type. So in EC2, you can have multiple types of usage. You can have bandwidth network kind of usage. You can have just runtime usage. And then the start date. So these combined, and the dates are bucketed. They're not perfectly unique. I think they start at the bottom of an hour. These identify a cost. So if I use this as a computed ID, then all my processing can grab just the latest value for a computed ID, and I get no duplicates. And the data lines up very, very well with what AWS says. It's not perfect. I think it's off by a couple cents here and there, mostly I think due to the timestamp conversions I do. But overall, I'm able to identify where my cost comes from. So the last one, and I hope this isn't overwhelming, is Azure. And this is almost one-to-one exactly what I do with AWS with a few tweaks. So in the cost explorer of Microsoft Azure, there is an ability to do regular exports to blob for your usage. So you configure that in a simple UI, jump it to a storage container, and then you can configure it to do daily or monthly, weekly, whatever you want to do, but it doesn't go less than daily. So daily, and I have it doing week to date, which means that for a specific week, if it's a Monday, it adds 10 records. If it's a Tuesday, it adds all the records from Monday and the Tuesday records, and it keeps going up to the end of the week. So that's a slightly different, but still challenging data duplication problem because I have lots of duplicates. From there, I do the transformation in dbt, I visualize in Looker, just like we've been doing. It's a really flexible pattern. Fivetran is used for the ingestion, again, because of its ability to respond dynamically to changes in the data. And Microsoft threw me a huge curveball that Fivetran picked up for me. If I had done a snowpipe approach, which I totally could have done, it would have broken it. It would have been hours of rework. I probably wouldn't have bothered to do it. So that's the power of having a tool like Fivetran that can take that grunt work and just do it for you. And you can focus on the higher level concerns of like a dbt transformation. So here's the data quality. Let's focus just on the top one. And these are the number of records I get per day. And I've noticed I got a lot of gaps. Also, my data doesn't go back as far as the other ones because I set this up back in October of last year as well. What happened was January 16th, Microsoft changed the schema of this report with no notification to me and added many, many more columns and repurposed and renamed a few other columns. So all my old data stopped being compatible with my new data. And Fivetran picked that up seamlessly for me, but I also started to notice drops in data. I would just go days where I had no charge in Azure, which is not true. Like I have storage accounts there that'll be charging fractions of cents every day. And then I even had recently a week where I went with no data that came in. I had a spike there that I know about. So I suspect that this is an issue with that update, with that change in format from Microsoft. The other issue is that these reports, they're not documented anywhere. There's no documentation explaining what the columns mean, which is embarrassing, I think, for a cloud service to say that they support exporting cost data, but they just have data drop for no reason and they don't explain what the columns are. I assume it's not a priority for Microsoft to make sure people can control their costs. But I have a ticket open right now with Microsoft for this. And to debug it a little bit, here on the bottom, I created an additional report, a fresh report that didn't exist before this cutoff. And I don't see the same data drops. So what I'd like to do is hopefully they come in and they can just give me the additional data. If not, I will merge these two sources and I'll just start pulling from the more accurate one. But this is where something in DBT called tests could really save me. So if I know that my data is likely to have dropped days erroneously, I can write a test in DBT that runs with every production run to ensure that I know about that data quality issue and it doesn't sneak up on me. And we'll see about some of these data quality issues in the report. I think the report's still useful, but it is certainly not accurate, 100%. It is missing data. So let's talk about the transformations we had to do. In DBT, I move it to stage. Again, that's mostly just timestamp alignment and column renaming to make it more consumable for anyone in the warehouse. And then I grab just the current ones. I do again, I calculate an ID because these do not come with reusable IDs either. And then I grab just the columns I need and then move into my combined costs. So again, I can see Snowflake, AWS, and Azure in a single table for executive summaries, but then I can do investigation for Azure on this table. And let's look at the transformation. Again, timestamps, got to move those. And then I remove line item duplicates, but these are slightly different than the AWS ones. These aren't just updates after the fact. They do have that, but it is for X to date reporting. So they have week to date and billing period to date, where they intentionally in each report have duplicates. I think the intention is that someone would go in and grab a single report for whatever's the latest for a specific day. And this makes it easier because you don't have to be a coder. You can just grab the file and put it in Excel, but it does make data cleaning tricky. But I found a way around this. Next, I prune columns just like before, and then I hash sensitive data. I found in Azure, it's like everyone's favorite thing is to put a client name in some amount of work. We separate a lot of our Azure work by the client that we're working on. So I couldn't show that. So we hash those. That saved me a ton of rework by being able to use LookML for that. And this is the transformation. It's a lot simpler than what I had in AWS, but I convert the timestamps and then I can do a computed ID. This time, no hash is needed because of the file directory that Azure uses. It tells me the range that a date is good for. So the third entry in a folder path is a range of dates. So the 21st to the 28th. I can use that as an ID and I'll take just the latest report for that week. And that's how I can get the latest information. And that's a lot more efficient to clean. The data itself is a lot smaller as well because we're reporting at the daily level, not at the hourly level. And Azure just kind of sends a lot less information. So this is a really efficient transformation. And this is the whole picture. I told you we'd come back to this. The Snowflake piece right here is just to speed up our queries and to clean some timestamps. And then S3 and Azure through Fivetran is to make sure that if the schemas change, which S3 it did when I asked it to, and in Microsoft it did just because they did it, and I don't know, no one cares. And Fivetran saved me hours of work on this. So this is a pattern you can use. We don't have GCP because we just don't have enough spend right now. That's changing though. We are seeing a huge pickup in GCP usage, so that'll be my next step is to add that here. But you could have this adapt to any kind of regular billing report that you want. If you have another SaaS service that exports it as a flat file, or even if you want to query it with an API, Fivetran is a great tool for getting that into your Snowflake environment. And from there, it's the same tools you're already using, dbt and Looker. This is what the whole thing looks like. And I'm really proud of this lineage graph. It's one of my favorite parts of dbt. And you can see how the individual sources feed up to their staging tables, to their analytics tables, and then our combined cloud cost unified analytics table. This is all kept up to date. I can't stress that enough. So Fivetran grabs these data sources 4 times a day, and I process them every other hour, along with some of my other data warehousing processes. And then Looker pulls the latest information every hour, so it caches it to make it really efficient. So let's talk about streams and tasks. We're at the halfway point, which was my target, so that's good. And let's go off-road a little bit. First, let's define streams and tasks. So Snowflake has 2 really powerful concepts for automating your workflows. Now, Snowflake does allow you to use other tools. It is not a walled garden at all. But if you don't have external tools that allow you to do this kind of stuff, streams and tasks are really important for automating your work. Let's first define a task, because I think that's pretty easy to understand. A task is just a scheduled Snowflake query. That's all it is. You define the schedule you want it to run on, and that can either be every hour, every X amount of minutes, every day, something like that, combined with who you want it to run as, so that'll run as the role, with a warehouse to run. And then you apply the SQL. Now, you can only run one statement within a task, so often these are combined with stored procedures if you have more complex logic. But it doesn't always have to be. A simple example of a task is that maybe every day I want to select how many users have logged in and push that into an audit table that I persist. That is something I could do with the task and would be kind of difficult to just remember to log in and do every day. Now, streams are more tricky. And I'm going to put a disclaimer out, especially if there are any Snowflake engineers on the call. I am not going to tell you what a stream is, like how it works. There's really good documentation on that. What I think is missing for folks is how to think about a stream. So I'm going to focus on that, even if it's not literally true. So streams. First, they're similar to processing queues. So if you're familiar with the concept of a queue of something like Kafka, where data is written to it, and then as it's processed and pulled from it, it's removed from the queue. That's really what these are designed to act like. You query them just like a table, which makes them powerful. So once you create a queue, it's going to track changes that occur to a table. And those can either be just the additions, or you can track everything that happens, a delete, an insert, an update, all that good stuff. And it exposes it to you in a table format, so that when you're doing your processing, you don't have to create a new table. You don't have to have this like processing area. You just query that stream, and it's as simple as this. But the powerful part is that once you have the stream set up and you process the data, as in you grab data from a stream, select star, it'll only return the new data you haven't processed yet. And if you insert that into a new table, if you do data modification of any kind, as soon as that operation finishes, the queue empties itself. The stream is now empty. So when you go back to grab more data, you only get fresh data every time. But you can still query it. The select star would not empty it. I would have to insert it somewhere or modify, actually process it. So these combined with tasks make it really easy to do change data capture processing on data that's coming in regularly. And I think that's a good example. Like, this is a good definition, but it helps a lot with streams to actually see them in action. So I am going to talk about a Netflix use case. This is obviously something I made up, but I think it will help give you an understanding of what we mean by the usefulness of streams and tasks. So moving into Snowflake here, and I can make this a little bigger. Now refresh. Great. So let's run a little bit of SQL here. First, I'm going to set my context, and this is what makes this script reusable. Anyone that wants to run this, as long as you have the permissions to create a task and you have a database and schema that you can create things in, you can run this. Just replace these values with your own values and it'll work. Next, let's create a couple tables. First, I want to create a Netflix rating events. So I think a lot of us are watching kind of a lot of Netflix right now with the quarantine. I know I am. And Netflix has a rating system. So if you see a show and you like it, you can rate it. It used to be numbers based, but now I think it's just a thumbs up, thumbs down. But let's imagine that it's numbers based again. So we get these events coming from all kinds of different devices, iOS, Android, your TV. So we're going to create a table here to store those events. And they're just going to be a variant, which means they're JSON. They're bundled up. It's going to be a web request that someone stored here. And then we're going to actually create a ratings table. This is going to show our the ID of the show that's been rated, the name of the show, and then the rating number. And the way that the variants come in, they're only to preserve bandwidth. They're going to only have the ID and the rating. So the idea here is take new data as it arrives and append this show title. And for that, we're going to need a Netflix shows table. This is going to take my ID of a show and give me a title for the show. So if I refresh over here, we can see my tables. They have nothing in them right now, but these are the 3 tables we'll work with. So as data is coming in, we're really going to be focusing on this events table. And that's where streams really shine. Data or tables that have data coming in regularly at unpredictable intervals that need to be processed in a way that would be inefficient to do without delta capture. So let's go ahead and add some TV shows here. These are in no particular order on Netflix, but I will point out that BoJack Horseman is the best show on Netflix. It's probably the best show anywhere, though The Sopranos is quite good. But the rest of these are just very good Netflix shows that maybe you've seen before. And so if I look at my shows, here's kind of my inventory of shows. I'm sure Netflix actually has a lot more detail here. It doesn't get complex, but simply we're just going to have an ID and then the name of the show. And let's create some streams. So streams are not hard to create. You should not feel intimidated by them. They just feel confusing at first. So all I do to create a stream is run create stream and point it to the table that I want it to process. These 2 streams will not interact with each other. So as A gets processed, B will not record those processing events. And it's common if you have a table like this rating event, where you may have lots of different kinds of events coming in that need to be processed in different ways, that you would have multiple streams. And each stream would handle a type of processing that you want to do. It's very efficient. And now let's show these streams. And we have stream A and stream B. These are ready to go. They're delta streams, which is a type of stream that you could dive into the docs, but I think maybe it's a little beyond what we need to discuss today. And now let's add an event, an actual event to our events table. The raw data is a JSON. We have a show ID and a rating. What we don't have in this case is a timestamp. So there's no way to know after a certain amount of ratings have been added, which one we've already processed without doing some really complex comparisons of our end table and our source table. So we're going to add this. And if I look back at my ratings events, we can see that it has been added. We have a new event. And the rating is 10 for show ID 0. And now let's look at the streams. If I select start from the stream, it looks familiar. This looks and feels just like a table where I have my raw data. I will have all the columns on my underlying table will be here just like you see them in the table, but I also have these interesting metadata table or columns. This tells me what kind of action was done to generate this data. It's an insert. It could also have been an update. We could also have a delete where this is the data that was deleted. We also get information on whether it's an update or not, and then the row ID. And this is a typically hidden column that uniquely identifies this row. And it's very useful to us if we want to understand what specific item was deleted when the raw data would not differentiate itself. And if I pull from stream B, same thing. It's identical. We get the same information. Now let's process this data. So this information alone, just the rating and the show ID, is not great to dashboard, because what I really want to see is like what show is getting a rating of 10. So I'm going to insert into our ratings table a show ID, show title, and a rating by first joining the Netflix shows, which is our catalog of shows and IDs, to our stream. And I'll grab where the ID is equal to the show ID. I'll also check to make sure rating is involved, because if rating is null, this may not have been a rating event. So this will handle bad data that ends up in the stream. And again, I'm processing from stream A. So let me go ahead and run this. And now if I look at my ratings, I have human readable ratings for this show. It's the BoJack Horseman show. It got a rating of 10, which is appropriate. 10 in this case is the best rating you can give something. So that looks right to me. This is good data quality and it's been processed. But the interesting part, and it's why I created 2 streams, is what happened in stream A. If I look at stream A, it is now empty. So if I ran this again, I would gain no information. I can run this as many times as I want, and I don't have to worry about duplicate data. That's one of the powerful parts of the stream. And I didn't have to understand how to identify new data because the stream is handling that for me. But interestingly, stream B still has this because I have not processed it. Stream B will maintain this. So one little caveat, this works based on your time travel period for your tables. So if you have data that hasn't been processed in 3 days, but your time travel period is only 1 day, you'll start to have issues. But typically, that's not a big deal. Just set your time travel to be like 20 days and then process it every day. And it's no problem. But that's something that has to do with how the streams actually work under the hood. So let's add a couple more ratings and see what happens. We're going to add 2 ratings. These are new ratings for new shows. And if I look at stream A, we have those 2 events. We don't have that old rating we already processed, but these are 2 new unprocessed ratings. And stream B still has all 3 from our first one and then these 2 new ones. So now I will pull the new data from stream A. This is the same query we ran before. And if I look at my events, double check, I have 3 event data. And if I look at my ratings, I have 3 clean ratings. Ozark, which is a phenomenal show, that got a 9. Master of None, I think it's hilarious. It's an 8. It's not perfect. It's pretty good. It's got some slow parts. So if you look at our stream A, again, is completely empty. We can run this all day and never get duplicate data. Stream B is still ready to be processed, untouched. So what happens if we delete data? So far, we've only been adding. So let's delete everything from our events. And we have stream A records these delete actions. So if we wanted to do some processing where, for example, say someone had sent a bunch of fake ratings data, and we know it's fake, we found out later, and we want all of our downstream processing to be cleaned, all you have to do is delete this. And if your stream has a delete processor that grabs the information and deletes from the other table where the values are equal to this, then you don't have to worry about bad data polluting the rest of your environment. The stream will help you with that. Now, something that I think was really surprising, I didn't know this would happen. In stream B, I expected to see 3 add events followed by 3 delete events, because that's what has happened to the underlying table. However, stream B folded it down. It understands that your deletes completely wipe out the need to process those adds. They're the exact same record. So if you have an environment where you have high churn on a table, like this events table, if you aren't doing a join, a materialized view could be used to do just flattening, right? And you won't have to manage it, but the materialized view will process continuously. So if I have data that arrives and then eventually gets deleted, then I will pay for it twice, once to process it, to be created, once to delete it. But if I batch those every 5 or 10 minutes, the stream will only show me data that needs to be processed. It'll withhold the creation and delete from me, so I'll spend less money. And that's something that's really interesting here. The other point about streams and tasks that make them a little more flexible than a materialized view is that I can do a join. Materialized view and Snowflake don't allow me to do this kind of join, which is kind of painful because most of what I want to do with materialized view is actually a join anyway. So that's where streams come in. But if all you're doing is just like flattening JSON, then I recommend a materialized view. It's a lot less to manage. And now let's talk about automate. So how do we automate this? This has been interesting for how we can process it, but it doesn't automate itself. So I'm going to create a task here, just like we talked about before, called the Netflix ratings event processor. It's going to be using my RTE warehouse, and it'll run every minute. So watch out, because almost every time I've seen someone really overblow their Snowflake budget, it was by having a task that runs constantly and just keeps a warehouse on. But I have a little catch here. So tasks allow me to only run when a specific stream has data to process. So this will check every minute to see, without charging me any money, if a stream has data to process. And if it does, it'll turn on the processor and process immediately. And if it doesn't, it'll just shut down. So no money spent. So this is the best, closest kind of stream processing I can get in Snowflake. And here, this query, this is the same one we've been using this whole time just to insert data. So let me create this task. The task exists. Now tasks, when they are first created, they aren't on by default. So you have to automatically resume them. So now this is going to check every minute, and let's add a bunch more records. And I'll add, don't want to forget, this Bojack record. That's added. So now if I look at my ratings, it shows me my old data. We didn't go back and delete this, but the new data has not been processed yet because I didn't run the command. I just sent a task on. So if I click this a couple times, every minute it will process. So you'll see here, we have a bunch of new records that just came in. And that's that task automatically grabbing the information and transforming it for me. I can walk away now, and any new data that shows up in my events will be processed for me into clean ratings that I can then point a BI tool towards. And then lastly, let's do something interesting. Let's find out what is the best show on Netflix. We have this ratings table. We can finally settle the debate. And it looks like BoJack Horseman is the best show on Netflix. That looks right to me. And that's maybe an example of how you can use and think about streams and tasks. I'll go ahead and clean all this up because I don't want this to keep running, even though it is protected. I just don't want to risk the overspend. So that's a deep dive into streams and tasks. It's okay if you didn't catch all that. If you want to run the SQL yourself, we have this public. We'll send this out afterwards. It's a really simple script, but I think it makes it easy to copy and paste this into your own environment and use it for your own processing. I use this at scale for our CloudTrail logs because the CloudTrail logs come in a way that are really difficult to process with something like a materialized view. It has a flattened process that isn't supported by the materialized view. So these streams and tasks really power our security monitoring. Let's talk about reporting and monitoring, because this, I think, is what a lot of people came here for, specifically the ones who aren't SQL lovers. And we're going to use Looker. I think Looker is really uniquely positioned for this type of project because it handles the row level data really well. It has a lot of governance controls that would be difficult to do on your own. And it has really powerful caching that makes it performant. Other tools are going to have trouble with this. They're going to have potentially bugs here and there. I know that when I loaded this in Tableau, it had a hard time showing me all the records I wanted because this information does go almost log level, not quite. And in Looker, it churned through it really quickly. Let's look at some of these dashboards. We'll run through them, I think, pretty quick. We're about 13 minutes out. The first dashboard is our Snowflake spend. So this is live data, relatively live, plus or minus a couple hours of our spend in Snowflake. The trick with Snowflake is that you get credits. So you have to apply a credit like dollar value. And for typical companies, it's about $3 an hour. That is without any sort of discount. And that's for the enterprise level. If you're at the HIPAA level or the virtual private cloud, that's going to be more expensive. And if you buy in bulk, it'll be less. So I would suggest putting in a parameter here, but for ease of compute, we just call it $3. That's about right for us. So I can see my total spend for the last 30 days. I can see how that has changed day over day. And I spend about $10 a day on Snowflake. I can also see my task activity. So this is something that's really hard to do in Snowflake because they don't natively show you what tasks are running. You have to run SQL and run multiple lines of SQL to get a feel for this. And it's not visual at all. Their cost reports don't show this. But that's a problem because if you have tasks that use the same warehouse, which is sometimes useful to avoid minimum bill charges for different warehouses, you won't be able to see which task is driving your spend. So down here, I have my Snow Alert CloudTrail flattening task warehouse. And this is the CloudTrail flattening task. I know for a fact they're one-to-one, and I can see I spent $92. But these other two tasks, one it caught when I was developing this, our Netflix ratings event processor. It picked that up. And then a snapshot Snowflake task history task. This is something that I'm doing to persist data directly in Snowflake. These share a warehouse. So if I look at RT warehouse, it's not clear what activity was driven from the task and what activity was driven from just normal usage of this warehouse. So this allows me to find if I have a specific spike in a task, I can know that's the task to focus my efforts on. I also have my last 30 days cumulative spend with a forecast line. And this is just a useful way for me to see at what points in the last 30 days was I above my average spend and below my average spend. I like this. Not everyone likes this kind of chart. And then I see my individual warehouses. So RTE warehouse, this is the main warehouse that I interact with. So if I wanted to filter to this warehouse, I can do that really quickly, and it will filter these other charts. So I can see daily I spend, it depends. So I've been preparing for this this presentation, so you can see big spikes in my usage, but typically I don't spend a whole lot on it. It's very efficient. And total spend in the last 30 days has been $47. But Snowflake, pretty simple. The charges are not that convoluted, and honestly, you can get away for the most part with their built-in stuff, except for things like task monitoring. Things that you really get advantage for are in AWS. This is where I'm really starting to see the advantage of having this information. So in AWS, the kind of questions I have, we have multiple accounts. So I want to see which account is spending the most money. In addition, I want to see what region is that being spent in and what service am I spending on. And then my actual question, once I've narrowed down to why I have a spike, is what specific item is causing me to spend too much money? So I can go turn it off or resize it. So really everything at the top up here is meant to allow me to filter and direct my interest. So like this has a spike. Let me go ahead and click this. This is on the 5th or on the 1st of May. So if I go up here and filter to that day, I can run my dashboard. And I see that I spent $35 in a single day. That's kind of a lot for us. And the service looks like AWS Glue leads the pack, but there's not one specific service. All of it came from EC2. Most of it's from my CDP account, which is our Cloudera account. So what I can tell is that we probably turned on a Cloudera data warehouse and did some kind of expensive computing. So this isn't a big deal. This was on for a single day, but if this were on for a long time, that might be something to notice. And these things can be very expensive. I've gone ahead and hashed the resource ID because occasionally people put client names in some of these resource IDs. And that's something that Looker made very easy. But this allows me to direct my attention in ways that would be difficult. And I always like to show this. If it's the past 90 days, basically most of the year, I can see a couple really big spikes here. And this, again, was driven a lot by our Cloudera account. That's almost one-to-one with our main usage account. And Glue is a continuous problem for us because I don't think anyone's even using Glue for anything interesting. So we're spending a lot of money just to have something run. And if I look at who created this, Chris here is a really good friend of mine, but he left the company months ago. So he has things that are on and still billing us that we need to go turn off. So this is why it's really easy to forget these small things and focus just on the spikes. But I'm much more concerned with this high average spend, and that's going to be Glue and EC2. Next is Azure, which, as I mentioned before, it has data quality problems. We're definitely spending more than $1.65 over the last 30 days. But this is the same kind of investigation we would have. I have the specific instances, the service family and location that spend is happening in, the total spend for the last 30 days, what service family it was in. So it's like, is it a database or storage or compute? And then the specific region. Something that I might notice is that I had kind of a big spike here on the 6th. So if I go to the 6th, which is very simple to do, that's just yesterday. Then it's 82 cents, which isn't a big deal. And we have a database on. So the resource group here would tell me more information if it wasn't hashed, and I can go find out why that's up. So if I go the past 30 days, 90. I could see a much higher level of spend.
Hey, Randy, real quick, had a question that came up a few minutes back. What is the data source for the AWS cost details, and can that data be found in an AWS S3 bucket?
Yeah, absolutely. So all of this data, every last piece of it, is from that report I mentioned. And I want to show you, but I don't want to risk showing a client name. but you would just go into, let me show you here, AWS cost and usage report. This is what you want to Google. You configure this. It's very easy to do. It's all UI driven. You just point it to an S3 bucket for it to drop into. I recommend adding the resource IDs, which is something you don't have to do, but it'll pay off, and storage is cheap. It's a free service. You don't pay for that first one, but you do pay for the S3 storage to do that. Then you can adjust it into Snowflake, and then you can dashboard it. And if you process the data, and we'll extend like how I did the hashing to remove duplicates, then this can be really, really efficiently visualized. And I'm doing it daily, but I can even go down to the hourly level and identify what specific things are causing me cost. And it's so flexible. I've actually built this same kind of processing in Tableau as well across all my clouds. And then I have in Sigma, which is another dashboarding tool, I have some of my Snowflake stuff. So don't feel like you're stuck if you only have Power BI or you only have a free tool. You can get started really simply just with out of the box configurations. Yeah, that's a good question. And again, though, I think out of all of them, Looker is the one that gives me the most power for a couple reasons. So getting away from the specific examples, like how do I action this data? This is useful if I'm investigating a problem, but I don't want to have to know every day to jump in here. So going back to our report, Looker allows me to do two really useful things. One is to send a daily report every morning to a Slack channel. That's an image of those dashboards updated that morning, so I can start my day with a quick Slack look, because I'm already in Slack anyway. And it's a public channel that anyone can join who's interested, and I can identify where costs are going. I also have usage alerts. So this is something that I could not do easily in another tool, where in, for example, my AWS spend, I have this little bell. So I set an alert that will email me at my email address, and I can send multiple people here, where my costs go up by $20. If I see a $20 daily spike in cost, I will get an email. And this is what I would consider a threshold of daily spend, where if it increases by that much, that's worth attention. But if it just goes up by $1, or if it exceeds a specific threshold, that's not as interesting. So it's a relative comparison. This is really powerful. And I have this set up on all of my major clouds here for the specific daily spend. I also have a total last 30-day budget amount. So I don't want to get stuck in an environment where I'm using the Azure alerter and it will let me know within a billing period that I'm over. But what if at the end of a billing period for like the last week, I was burning really hot, and then for the new period, I'm burning really hot again? That will alert me until I'm halfway or more into the next billing period. But the rolling 30-day alert gives me much more power to take action before it becomes a problem. And the way that looks in Slack is that I get just this simple. Anyone, you don't have to have a Looker account. You don't have to log in. I have an executive summary version as well for folks that don't want to see all this detail. But for me, I can jump in and make sure this little line hasn't spiked too much and that none of these need my attention. That executive summary, it's not a ton to look at because there's less charts. You really only get the type of cloud, the day, and the dollar amount when you're combining these sources. But I can see, again, this is a rolling 30-day accumulated sum of spend, and I can see where I'm above or below the forecast line. Average spend, we spent about $25 a day over the last 30 days, and then total spend, not quite $1,000. Yeah, great questions. And before we get to the exact questions, we're getting up on time here. I did want to let you know, this stuff is all really reusable, and you can go do it on your own. You can spend weeks to kind of gain the insight, the experience that we spent a lot of time and money to gain, or you can just reach out, because we package this as a small bite-sized offering that anyone can leverage. You do not have to enter a huge procurement process with us. We work with small engagements all the time. And this is our Accelerator service. So this is either a 3-day or a 5-day engagement. We can go on your bite-sized budget based on these times, and we can lead by example. We're so confident that once you see the value of doing these kinds of data-driven efforts, that you'll come back and use us as a trusted advisor, that we offer these way at basement prices. Honestly, I'm shocked that we're able to offer this. So check this out. This is at hashmapinc.com/quickstart-save on cloud. This is a really good thing to give your executive team. If you've been trying to find a reason to use Snowflake, trying to find a reason to modernize your stack, this is a great thing to give to your executive team and tell them that we're not just doing it to be cool. There's actual money on the table that we could save. And with that, let's open it up to questions. That's it. That's all I had.
Hey, Randy, excellent. I think everything that you've addressed, we've kind of peppered you with during the broadcast. So
Perfect.
let me do one more check on YouTube. In fact, shout out to Trey Dempsey. He helped get a question answered on the YouTube channel.
Nice.
And I think we are in pretty good shape. A lot of thanks coming through for the presentation. We're right at the top of the hour, unless I see something else coming through. I think, number one, thank you. Really appreciate all the time, prep, and energy put into putting this thing together today. And certainly thank you to everyone that joined and took their time to come and hear what you had to say. I think that what you shared will certainly help everyone on saving money in the cloud. And as Randy said, if you need some additional help, definitely reach out. The 3 or 5 day quick starts are meant to get you up and running really, really quickly. Randy, also, you talk data and cloud weekly on a podcast, Data Rebels on Tap. You've had some great guests. I know you've got some more guests coming up, so people can catch you there. Hashmapinc.com/Data Rebels on Tap. And we will also have the on-demand video and slides available at hashmapinc.com/events. So, Randy, any closing thoughts?
I guess my last just closing clause, this stuff is not hard. It really is not. The tricky part is the ingestion. And if you use one of those ETL tools, the rest is just simple stuff anyone would try to do. So go give this a try yourself. Impress your boss with some unified cost data, and don't feel intimidated by any of this.
Thanks, Randy, and thanks everyone. Have a great rest of the day. Really appreciate you joining.
Thanks.